Today's lesson, section 11.0, we're talking about intro to conic sections. So in class, I will show you some stuff with a 3D graph for how we get our conic sections, show you the equations, or some of the equations that we use to get those. I'll also talk about degenerate cases for conic sections, and then we'll prove quadratic formula, and I'll help you be able to program your quadratic formula into your calculator, but we'll do all that stuff in class tomorrow. But for this, for your assignment, we need to be able to complete the square and to use the discriminant properly, so we want to kind of talk about those things first. So completing the square, so remember that if you have a formula or equation that's x squared plus bx plus c is equal to 0. Notice that there's no value in front of the x squared other than 1. And so to complete the square, I need to be able to split up this bx so that we can get a value here that makes sense. Now, because c is not that value, it moves to the other side, so we get a statement that looks like this over here. And so what we want to do is to be able to find this value so that it makes it a complete square. So why we use the words completing the square is that if you have this x squared term, that's like having a square where you have a length of x and a width of x. Okay? And then you have this other term, bx, so that means that you have some part that you could split up evenly, because remember, you want to make a square with this. So you want to be able to split up b times x, so it has a length of x here, but it needs to have a width of b. Now, the width of b you can't put on just one, you need to split up evenly, so we would divide b by 2. Okay, so it would be b over 2 and b over 2 on both sides. Okay, and then from there you get this little thinky box that we need to figure out what its area is to complete the square. So that's the portion that we're going to put into this blank over here. And so then that ends up being b over 2 times b over 2, which gives you b over 2 squared. Okay, so whenever we take this, we'll put b over 2 and put it there. Okay, and that'll help us to complete the square. And then it ends up where when we complete, or when we want to factor out the x squared plus bx plus b over 2 squared, then because of our new square that we made, we have sides of x plus b over 2. And then you can combine those to get x plus b over 2 squared. So I always like to say the number that you put in here and here is going to be this b value divided by 2, but before you squared it. So like if I had a 6 there, it would be a 3, because then we take 3 and square and get a 9 for the blank up above. Okay? So now we want to practice this. So example 1 says complete the following square. So here, now the 17 does not complete the square, so it's not what b over 2 squared would be for 10. So we want to add it to the other side to get it out of the way. And we create a blank in its place. Now, to keep your equation the same, you've got to do the same thing on the right. So what you do to one side, you do to the other. So now we take 10 and we divide that by 2 and we square that. And so 10 divided by 2 is 5, squared is 25. So then that's what I'm going to add to both sides. So now when I do my parentheses, what I got when I divided 10 by 2 before I squared would be 5. Notice that this has the same sign as well as what the sign is here. So if it was minus 10, then we would have a negative 5 for both, because negative 10 divided by 2 would be negative 5 as well. And then that gets me a 42. So then you can now put them together because you have two of them. So you completed the square. Okay. Now we want to also be able to solve by completing the square, which is what you're going to be doing in your homework. Now, to complete the square, I don't want this number in front of x squared to be anything other than 1. So I need to divide everything by that number. So dividing everything by 5 gets you x squared minus 4x plus 2. And then 2 is not the number that we want here, so I have to subtract 2 to both sides. So I create my blank on both sides to keep it balanced. Half of negative 4 squared would be 4, and then I add both sides by 4. Okay, so now what I got before I squared was negative 2, so I put x minus 2, and then negative 2 plus 2 would be 2 on the other side. So I have two x minus 2's multiplied to each other, so I can say x minus 2 squared is equal to 2. Then from there I want to solve, so I want to square root both sides. Now remember that because you squared or square rooted both sides, that means that you need to put in a plus or minus. And so then from there I want to add both sides by 2. So then x will equal 2 plus or minus square root of 2. Okay? And then that would be my solution for this problem. Next, we'll talk about the quadratic formula, and we'll prove this in class, like I stated earlier. But the root of the quadratic equation ax squared plus bx plus c is equal to 0, where a is not 0, so that means that it is a quadratic that you're doing. Okay, you can't do this with a bx plus c because that's just a line. And for that one, you don't need the quadratic formula. So then you get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, I know you know how to use that. You just plug in the values. But here, we also want to be able to talk about the discriminant, because they're going to ask you to take an equation and define how many real solutions there are based off of what your discriminant is. So the discriminant is the value or the expression that's underneath the radical. Helps us determine whether we have real or imaginary or no solutions, or one solution. So taking a ax squared plus bx plus c equation, the determinant is b squared minus 4ac. So if that discriminant is greater than 0, then the equation has two distinct real solutions. If it's equal to 0, that means it's 1. Now, if you think about that, if it's 0, that negates the plus or minus, so that's why it's only going to be one solution instead of two. And then if it's less than 0, then that means that you have no real solutions, because you have two imaginary solutions instead because of the negative underneath the radical that occurs. So you have some i's that happen. Okay? So for this example, we want to use the discriminant to determine how many real solutions each equation has. So my b is this negative 4. So negative 4 squared minus 4 times 2 times 1. Okay, so then that gives me 16, and then negative 4 times 2 is 8. So it gives me a discriminant of 8. So since it's a positive number, that means I have two real solutions. Okay. Letter B says that I have 18x squared minus 10x plus 11. So doing the same thing. So I take negative 10 squared minus 4 times 18 times 11. So negative 10 squared is 100. And then negative 4 times 18 times 11 would give me 792. So 100 minus that would give me negative 692. So that's my discriminant. Because it's less than 0, that means I have no real solution. Okay? And that's how we would do stuff with discriminant. So I'll see you in class, and we'll talk about the other stuff at that time. Okay? Have fun.